Hello, let's continue our Sudoku adventure with 7 Circles by Jonesy. So this is Jonesy's premiere to Sudoku Adventure, so everyone welcome Jonesy as a new setter. So let's go over the rules to this puzzle. So we have normal 6x6 Sudoku rules, so in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have double arrows in the grid. They're called arrows because they're similar to the arrow constraint in some ways, but there's not actually any arrows involved. They actually look like between lines, but they are not. So the way double arrows work is you take the digits in the circles, whatever they are. Say this is, I don't know, 2 and 6. That adds to 8. That all of the digits along the line that connects the two circles must add to that same sum. So we could do, for example, 3 and 5. So these add to 8 and these add to 8. So here, it's almost like a reverse arrow. We could do like 1 and 2, that adds to 3. We'd put a 3 here. This here is just 2 overlapping double arrows that happen to share this circle. All right, in addition to that, all of these circles are also counting circles. So if a digit appears in a circle, it indicates exactly how many circles contain that digit. Excuse me. So, for example, if I were to put a 2 here, that means exactly 2 of these circles have a 2 in them. So I could put like another 2 here, and then that would be it. I'd have to put one other 2 in, but I can't put any more. It's exactly 2 2s. And that's it. Those are the rules. There is a link in the description if you'd like to try it yourself, and I'm going to get started right now. All right. Let's get started by counting the circles. We have 1, 2, 3, 4, 5, 6, 7 circles. So what do I know about counting circles? Well, the digits that appear in the circles, the unique digits that appear in the circles, add to the number of circles that there are. How do I know that? Well, if a 2 appears in the circle, that uses up 2 of the circles. If a 3 appears in the circles, that uses up 3 of our circles. I can't actually do that right now. Let's do it that way. And so the 3 counts 3 of the circles. The 2 counts 2 of the circles, right? So if a digit appears in a circle, it uses up that many circles. We have 7 circles, so the unique digits will add to 7, right? When I put the 2 2s and the 3 3s in there, that took up 5 cells, 2 plus 3. Took up 5 of the circles. So the other thing I know is that these 3 are different digits. So we have at least 3 different digits in our circles, but they add to 7. 3 digits adding to 7 has to be 1, 2, 4. You cannot have 4 unique digits add to 7. 1, 2, 3, 4 already adds to 10. So this is going to be 1, 2, 4. And in fact, naively, all of the circles have to be 1, 2, 4. But I will say that we already know where our 1 is. It's in this row. So none of these are 1. Okay, so I know that this is a 2, 4 pair, which means that this double arrow adds to 6. So these 2 also add to 6. Well, they can't use 2, 4. The only way to add to 6 in 2 digits is 1, 5 or 2, 4. So this has to be 1, 5. And then we're left with a 3, 6 pair over here. Nice. If this wasn't a 1, it would be 2, 4, and then this would be 1, 5. And that seems okay. How about here? This is either 1, 2 adding to 3, or 1, 4 adding to 5, or 2, 4 adding to 6. Okay, let's think about this. We need 4 4s. One of them is here. Ah, look at this. We have this 2, 4 pair here. So this is the 1. That's even easier. But where are my 4 4s? 1, 2, 3, 4. Yeah, I can cover all of the circles in 4 rows. So each row has to contribute a 4, right? Because I can only have 1 4 per row. So I'm going to have a 4 from this row, a 4 from this row, a 4 from this row, and a 4 from this row. That's all of our 4s. So we know it's in this 2, 4 pair, but that means these 2 are 4s, right? So that's a 2, that's a 4, that's a 2, that's a 4. I guess we could have also said that the 2, 4 pair had the other 2 in it, right? The 1, 2, 4 had the 2 in it, and the 2, 4 pair had the 2 in it, so the rest are 4s. Anyway, 4 plus 1 is 5. 4 plus 4 is 8. How are we adding to 8 in 2 cells? Well, we can't do 1, 7. 7 doesn't exist. 2, 6 would be like this, or 3, 5. Can't do 4-4 because of many reasons, but even in a vacuum, we can't repeat the 4 in these two cells. So this adds to 6, so this is 1-5, meaning this can't be 5, so that can't be 3. In fact, that leaves 2-3-6 here, putting the 6 up here. What about this triple? We know the 2 is up here. Oh, actually, the 2 is placed. This 2 and this 2. Place that 2. And so then we're left with 3-6. That's a 3-6 pair. Where's 4 in this column? Right, these two 4s look down, so 4 is here. And so then this is 1, 1-2. Okay. Can I do what else can I do Sudoku wise? Down here we need a 3-6-5, 3-5-6. There's definitely a 5 down here. I need a 1 and a 4 up here. This cell can't be 1 or 4. We have the 1-5 pair and the 4. So 1-4 go here. And in fact, the 4 is placed. That's the 4, that's the 1. That's 5 and 1. That's a 5. Okay. So this is 3-6, and then down here is 3-6. In fact, this whole row is 2-3-6. All right, what's going to resolve this? I can still do 2-6 or 3-5. I think both of them are still viable. This is... Oh, this is 1-5, but the 1 tells us the order. That's 5 and 1. That gives us the 6. 6 plus 2 is 8. And I think that'll do it. Let's see. We get the 1 and the 2. We get the 3 and the 6. The 6 and the 3. 5, 1, 6, 3. We get 3, 2, 6, 3, 6. 3 in the corner is deet dooting. Over here we get 3 and 5. And we're done. Very nice. Cool puzzle, Jonesy. Nice debut to Sudoku Adventure. Thanks for joining the team. Really neat puzzle. I enjoyed it. I hope you enjoyed it as well. If you did, then why not leave a like, subscribe, and a kind comment below.